Okay, it should be good. Okay, so what are we going to be talking about today? We're going to be talking about how gear ratios slows down the engine's angular speed, right? So the engine is turning really fast, a couple thousand RPMs, right? And that's going to get geared down in two spots. It's going to get geared down on the transmission, and it's going to get geared down again on the differential, okay? And then your angular speed at the wheels will be slower than your angular speed at the tires, or at the engine, which is what we want. We don't want our car going, 5,000 RPMs at the wheels. That's really fast. Okay? I don't think the rubber can hold up on that. All right, so what we're going to do is we're going to talk about how that works. So we looked at some of these common ratios. These are some of your common differential ratios. Now, your ratios inside of your transmission, okay? The ratios inside your transmission, that varies from manufacturer to manufacturer. They're not all the same, okay? Some of us have multiple speed cars. Some of us, any of you guys have like a 5-speed car?
Yeah, I got a 7.
Okay, my van only has 4, right? 4 in an overdrive. Does anybody have a 6-speed car?
I got a 7.
We have like a new Camaro, Mike. 7? I don't know if they, I'm sure they do. A Lambo probably does, right? So all of us have different ratios in there. They're all made different, so your transmission gearing, those are not down to pretty much 3. But these are the 3 common differentials, which we'll need, okay? All right, so before we get into that, let's talk, answers. No answers. Okay, there we go. So before we talk about how the ratios and the linear and angular speed are related, let's do a quick review. I know it's been a couple days since you guys have talked about this. So, quick review on how we do this. So, angular speed. Can anybody sum up what angular speed is? Just like an informal, hanging out at a party kind of definition.
Yeah.
What is it? It's like an angle. Yeah. Well, what about the angle? It's how much it changes with respect to time. Yeah, it's how much an angle changes with respect to time. That's angular velocity or angular speed. That's fine, okay? So, what kind of units do we have for angular velocity or angular speed? Anybody know? We have some units. What kind of units do you know? What measures how fast something rotates? Think about a car. RPMs, thank you. So, RPMs, and I'm going to leave that one up there because that's the most common one we're going to use. That's definitely the one we're going to use today because it relates to a vehicle. So, RPMs, does anybody remember what the formula is for angular speed? Okay, angular speed is going to be omega, which is this, right? Is equal to the linear velocity divided by the radius. That was that thing that we learned before, right? So V was linear velocity, R was radius, the looking W is omega, right? All right, so that's how that's related. Let's talk about linear speed. On linear speed on a car, we usually use what kind of measurement? What kind of units? Well, yeah, that's true. We can write that down. So V equals omega times the radius. That's true. Angular speed times radius. But what are the units that we typically use for a vehicle, for linear speed? How fast you're going? Miles per hour, yeah. It's in America. So miles per hour, right? That's what we use for our linear speed. Okay, now, we talked about this. This was Kramer's lesson, Basista's lesson, right? So you got Kramer, you got Basista. You're going to sandwich them together, make some awesome combo there, and then you're going to have how your vehicle works, okay? So that's the goal today. So, gear ratios. Let's talk about some gear ratios. Let's say I have something at a 2-to-1 gear ratio. I have something spinning, let's say the engine's spinning at a 2-to-1 ratio, okay? Or it's spinning at a certain angular speed, and it goes into a ratio that's 2-to-1, okay? So that means for every 2 times the engine spins, the output is 1. So if I have something spinning at 1,000 RPMs, what's going to be the output? 500, exactly. It cuts it in half. So a 2-to-1 ratio will cut it in half. Now, on a car, it's a little bit different because it's going to go to a 2-to-1, and then it's going to go into something else. So these are some just general numbers. These are not exact numbers by any means. But let's say you had a 2-to-1, and then it went into a 3-to-1. So you have 2 ratios. It's coming in, it cuts it in half, and what's that 3-to-1 going to do? It's not going to cut it in half. It's going to cut it into thirds, okay? So what's the overall effect? And now this is something we did not talk about. We're going to talk about it real quickly. It's not very hard to do. The overall effect of this, if you have a 2-to-1 ratio, going into a 2-to-1, then going into a 3-to-1, is going to be simply multiplying the ratios together. So you got a 2-to-1, a 3-to-1, you multiply them together, 2 times 3 is? Oh, you guys are on it today. 6-to-1. All right, so it's a 6-to-1 ratio out, right? It cuts it in half and it cuts it into a third, which is a 6. It's the same thing. So if you want to know the overall ratio, we simply multiply like if this is the transmission, so that's transmission and this is the diff, okay? You just simply multiply these two numbers together and you get the overall, okay? That's it, and that's at the wheels, okay? So we have engine, goes into transmission, breaks it down, goes into differential, breaks it down, and that's the overall ratio at the wheels. And that's how it works. Not too hard, not too complicated. We're going to start off easy, then we're going to kind of step it up a little bit. Okay? Does that make sense?
I do 2 times 6.
Yeah, 2 times 3 is 6. That's it. Easy as that. Okay, let's take a look at an example. Oh, okay, so what are you really doing here? It's just a combination of the lessons I taught, which was angular and linear velocities, divided by what Basista taught, which was gear ratios. So you take Kramer, you divide by Basista, bam. You have a linear speed with the gears in it. That's what we're doing, okay? So that's the idea. So the gear ratio is directly affected by, and all you have to do is divide, okay? All you have to do is divide, okay? So let's look at an example of how this works. Ooh, answers, no answers. Okay, answers are gone. Okay.
Go back.
No, what, you just want to write down the answers? No.
Yeah.
You gotta earn it. Okay, let's keep it simple. What would the angular speed if the motor was running at like 400 RPMs, which is like very low? Okay, that's not realistic. I'm just trying to keep it easy number. So 400 RPMs, right? And it goes into a 2-to-1 gear ratio in the transmission. So that's exactly right. So how did you do that?
400 divided by.
So 400 RPMs, okay? And you're just going to divide it by the ratio. So you're not going to use the 2, like it's a 2-to-1. You're just going to divide by that front number. You're going to divide by 2. So you're going to divide by the 2. And that gives you your new angular velocity, which is going to be 200 RPMs in this case. All right, that's easy. All right, so what's the main idea here? Well, the main idea is angular divided by gear ratio. That's it. That gives you your new angular speed. It just breaks it down. You just divide. It's easy. Okay? Let's bump it up a little bit. Let's say you have a rear differential that's a 410. That's a 410 that we just looked at. We just counted the teeth on it, right? That was a 410 differential. So let's say we had a 410 differential, and that's off of that Ford Ranger, right? So you have a Ford Ranger running at 615 RPM. So the drive shaft is turning at 615 RPMs. And we're going to go into a 410 diff, right, in the back. What's the angular speed at the wheels? How do we do that? Very easy to do. We're going to go 615, right, and we're going to divide by 4.1. You guys are just like on it today. 4.1.
150 RPMs.
And you get 150 RPMs. Is everybody okay with this? Is this easy enough? All you're doing is taking angular speed divided by gear ratio. Everyone good with that? So, start at 615 RPMs, now it's down to 150, which is good. That's what we want. Okay? Kind of. I mean, it depends what you're doing, but we think we want it, right? Okay. So we did an example with the transmission. We did an example with the differential. Guess what we're going to do now? Combo. Put them together. Okay. So, well, answers. No more answers. Okay. So, get out of here. You didn't see that. All right. So, combo. These are specific numbers from my dream car. Okay. This takes me back to when I was in your shoes. I was a junior in high school.
What was it?
And they came out. It was a 2004 Chevy, the Corvette.
Was it built?
C06. Okay, and this was like the end-all be-all cars when I was in high school. They had a blue one. You might remember the cover. Back in the day, they had this Corvette. It was like the Blue Demon versus the Blue Angel. The Blue Angel was a jet fighter, right? and then they have the Corvette below it, and it's on YouTube. You can check it out. Not now. You can check it out later. On your own time. But the Corvette race the jet, right? No, not right now. Later, and then they were seeing who was faster, right? I remember seeing it on the front of a bunch of magazines, and I was like, oh, I gotta have that car. I just gotta have that car. So that was my dream car. Still is, but you know, because I'm teaching. If I were to maybe went a different route, maybe. Who knows? But I don't know. Maybe we'll have to look on Craigslist. I don't know. I'll have to check it out. I don't know. It's probably still pretty expensive. So that was my dream car. So we're going to use my dream car for the rest of these examples. And these are real numbers off of that car. Okay? So that car, if you were to put it in first gear, okay, its transmission is going to be 2.97 to 1. That's its first gear transmission. And its rear differential is going to be 3.42 to 1. Okay, so those are its two ratios. So let's do a real life example. Let's assume that you had a 2000. You have that car. You have my dream car. You're sitting next to the fighter jet right next to you, and you hold it at a steady 200 or 2,000 RPMs. What's going to be the rotational speed at the back wheels? So this is how we're going to do it, right? So first thing we need to do is we need to find the combo of gear ratio. And it's as easy as what? What do you do to get the two gear ratios together? Multiply. Perfect. So the gear, all right, so the gear ratio is going to be 2.97 times 3.42. Okay? Multiply that together, you're going to get a total gear ratio of, because I've done it like a billion times today, 10.15. Thank you. Maybe I didn't do it enough. 7.4. So the final gear ratio at the wheels, so from engine to wheels, is 10.1574 to 1. Really, that's the final gear ratio. Okay? That's the number we're concerned about. We're not concerned about first gear in the differential now. We just need that number because that's the combo. Okay? So now we're going to take that combo and we're going to divide it by the angular speed. So the angular speed we know is 200 RPM. So we have, or 2,000. Good eye. 2,000 RPMs. And we're going to divide it by this 10.1574. And that's going to tell me how fast my wheels are spinning. Okay? So we can work that number out on the calculator. Let's see what we got. 2,000. That's the decimal portion of this multiplication.
Oh, okay.
Yeah, you got me. All right, divided by.
It's 196.
Oh, thank you. Okay. All right, so yeah, I get 196.9. You want to just call it 197, and we'll call it a day. So 197 RPMs. Okay. So, well, if you round up, right, 160 or 196.9, we're going to call it 197. So the wheels, even though the engine's running at 2,000 RPMs, the wheels are only turning at 197 RPMs. Does that make sense? Everyone following my math there? Okay, you guys, I'll take that. All right, so let's figure this out. So here's an interesting question. So if that Corvette's tires rotated one full rotation, how many rotations of the engine did it rotate? Or how many rotations of the crankshaft happened? So if you know the gear ratio is this, guys, right? You know this is the gear ratio in here, this right here. That's the gear ratio. And the tires move one rotation. How much? That's it, right there. So look, guys, if this is the gear ratio right here, all right, and the tires move one. This is the wheels. This is the engine. Okay? Engine goes 10, wheels go 1. Got it? So engine did 10, wheel did 1. Engine did 20, wheel did 2. Got it? That's how it works. Okay? It's very easy. Not very hard to do. See how I got that? But this number came from above. From that. Just multiply the two gear ratios together. Okay. You ready to step it up? Do we step it up next? No, we got one more example. Then we got one more. This is a good one. I love this one. No. Oh, answers. No more answers.
3.08.
I got to clear these all ahead of time. All right. So here we go. Now, this is something you guys like to do, and I'm not 100% sure you guys even understand what you're doing when you try to do it. So let's talk about this. Let's say you got that nice Corvette, and you got bored, and you're like, you know what, I'm going to be crazy. I'm going to change that differential ratio in the back, right? Anybody change their differential before? You have to do it on your mud tires, on your trucks. No? Good, don't do it. Just leave it as it is. But let's say that you're one of those guys who's like, yeah, I'm just going to change it because I'm cool. All right, so you're going to change your differential to a 308. It was at a 342. You're going to change it to a 308. Before you do any calculations, no cheating, is this going to have a faster or a slower angular velocity if you go from a 342 to a 308? What do you think? Hands up if you think faster. Hands up if you think slower. Okay, so let's think about it, right? 342, is that a bigger number or a smaller number than 308? Bigger. So when you do a bigger number as your gear ratios, do you get more turns or less turns per engine rotation? You get less. So it's going to go faster. So let's watch this number. So this is going to go faster. So when you put a lower gear ratio, a 308, into your differential from a 342, it's going to turn faster. It's closer to the engine speed now. It's closer to that 1-to-1 versus being big. So let's watch the map. In case you're a little bit iffy on it, let's look at the map and see if it works out. So now my first gear is still the same. It's still 2.4. Shoot, what was it? 2.4 what? For the first gear? 2.4 something. 2.97. 2.97. That's what I was thinking. I'm sorry, you were right. 2.97. That's first gear. Okay. All right, and then you're going to multiply it now by the new differential, which is 3.08. All right, that's going to give you a number that should be smaller than 10.15. Let's find out what it is. What is it?
Oh, it's
9.14?
Yeah.
Well, hold on. You're ahead. 9.14?
1.4, yeah.
Okay. So 9.14 is our new gear ratio. 9.14 to 1. That's our new gear ratio. So if we take 2,000 RPMs, that's our angular speed, all right, and we divide it by this 9.14, we're going to expect to get a higher number. We're dividing by a smaller number, so we should get a higher number as our revolutions per minute at this point. So let's find out. So 2,000 divided by 9.14, boom. 218. 219. Let's call it 219. So 219 revolutions per minute at the wheelbase, which is higher. The other one was what, 197, and now we're going to 219. So for you boys that like to put change these differentials out just for the fun of it, know that if you put a lower number in the back, it's going to go faster. If you put a higher number in the back, it's going to go slower. Is there an advantage? Is there an advantage to putting a higher differential in the back? What happens if the engine's going slow? You do lose top end speed, but what do you gain? Torque. You gain torque. So if you go with a 410 instead of a 342, you're going to gain a little more torque. You're going to be able to stay in that low gear a little bit better. Okay. So for Buddy, maybe that makes sense, but no, that's why you're doing it. Don't just start talking with your buddies like you think you know what you're talking about. Just saying, oh, I swapped it up. But you don't. Now you know why. Okay, that's good. All right, so let's talk about. All right, you ready? Because we're about to step it up to the next step, and the next step is like it's like an 8-inch step, right? And if you don't get this step, what's going to happen is you're going to go to the next step and you're going to trip because it'll be too big. So is everybody okay with what I've covered so far? You suppose? Talking like a nod, maybe like a head nod, or how about maybe just like a don't stare at me, like
okay,
like you got it.
I mean, I have the next answer.
Okay, all right. Well, let's roll it. Let's figure it out.
197 RPM.
Oh, answers. Okay, no more answers. Okay, all right.
You said that for the last two times.
Yeah, don't worry. I'm gonna catch the next one. I'm gonna catch the next one. All right. So here we go. Let's talk about linear speed now. Now we're gonna take it from the angular speed to the linear speed. How is that angular velocity related to linear velocity? Now remember back to this, guys. This is our formula. We know that linear speed, or V, is equal to omega times the radius, right? So all I need is the radius. I already know how to find omega. I need the radius. Now, there's something important we got to consider here. When we're talking about the radius, we're talking about the radius of the whole tire, right? So let me give you one of my famous drawings. Here's a tire. Isn't that nice? A nice tire right there.
It's like a donut.
It's not a donut. There's
Looks like an apple.
like treads on it and stuff.
Or donut.
Okay, so you got a tire, okay? The radius is from this point
It's an eyeball.
to this point, the outside tread, it is not from here to here. That is not the tread. Have you ever seen those numbers on the side of your tires, right? It says like, I don't know, like 235 R what? R20. So what's that R20 mean? That's the rim size. Very good. R20 is the rim size. That's from here to here, okay? But that's not to the outside tread. Now, in order to do these calculations, we need to go to the outside tread. Does that make sense? So, will your speedometer be a little bit off? I mean, minutely off, mathematically off, if you have bald tires versus big old thick mud tires? Yeah, it'll be a little bit off. So, let's find out by how much, okay? Okay. Formula. Here we go. We're going to use that same Corvette. We're going to put it in first gear. And we are going to hold it at a steady 2,000 RPMs. How fast are we going to be able to go? How fast can you go in first gear? How fast? 30 miles per hour, 20 miles per hour. Now, this is a Corvette, though, right? I don't know.
Probably like
15? Only 15? What do you think? All right, so we're going to put it at... All right. Well, let's find out. So, 2,000 RPMs. We're going to put it at 2,000 RPMs. This is first gear. See what we get. Yeah, 2,000 RPMs.
Oh, like 7.
Okay, all right, let's find out. All very good estimations. So let's find out which one's right. Okay, here we go. So we need the gear ratio. So the gear ratio. Okay, it's going to be equal to this guy times this guy. So we got 2.97 times 3.42 equals, and I think we know that from the last example on the other side,
Yes.
10.1574, right?
Yep.
Okay, that's the new gear ratio. That's our combined gear ratio. Okay, so what is our angular speed? Our angular speed, we know, is 2,000 RPMs divided by the gear ratio, which is 10.1574. And that gives us a number, and I think we've done this number before, 197, right? Rounded. So we're at 197 RPMs. That is our angular speed. That is our W, or not our W. I said, oh, that was terrible. Not our W, our omega. Our mega is that. Now all we have to do is multiply by the radius. To multiply by the radius, we do a little bit of unit conversion action, and voila, we know the speed. It's as easy as that. Okay, so here we go. Our radius, it's on your paper. I'm just moving it down. I just need a little bit of room.
Hey, I got it.
There you go, right there. All right, I just need a little bit of room. All right, 13 is our radius. 13 inches is our radius, so here we go. Let's do this workout. So we got the velocity, or the linear velocity, is the angular velocity. How are we going to write that? 197 revs per 1 minute. You see how I wrote that? Revs per minute. Okay? So that's my angular velocity. Now here comes my radius. Ready? Now you got to be careful here. This is the tricky part. Radius is 13 inches. So 13 inches. That goes on the top. 13 inches is related to what? A radius and a blank are the same length. What's the blank? Radian. Very good. Radian. So 13 inches is a radius, 1 radian, or 1 rad. Okay? So there's angular velocity times radius, and we should have our answer. But the problem is we're going to have our answer in the wrong units. So we have to do some unit conversion. Again, yeah, all right. So 3 things we need to do to make this work, guys. First thing, we got to get rad and revs need to cancel each other out. I think we know how to do that. We'll do that. Pain, I know it is. It's fun though, isn't it? Oh, I love it. It gets me excited. All right, so then we got to get minutes into hours. Then we got to get inches into miles. All right, 3 things. First color. Let's go red.
Yeah.
Okay, well, careful. careful, careful. So radians are low, so radians need to go.
Too high off.
Well, it's on the bottom.
Radians on top. Right?
Yep.
Too high.
Radians on the top, revs on the bottom. One rev has how many radians? 2 pi. Very good. 2 pi. Very good. Okay, nicely done. All right, I'm going to claim that you guys have actually taken care of your rotational units. So these guys are taken care of. That's great. Now, what do you want to do next? Minutes to hours? You want to do that?
Yeah.
All right, let's do it. All right, minutes are low, so minutes go. Hi, yes, sir, ma'am. All of you guys. All right, so 60 minutes
1 hour.
to 1 hour. Yes, indeed. Okay. All right. Now I think we've taken care of minutes. That's great. Now we're in hours. Now we got to do inches. 2 miles. So now I'm not very good at this. Maybe I need to memorize this conversion. But if I go, well, that's true. All right. So, but I have to go inches to feet first, right? So inches are high, so inches go low. So I know there's 12 inches in 1 foot. I know that. That's something that you know. If I knew how many inches were in a mile, I could save myself a step, but I'm not good at that. So, all right, I'll just do it one more time, though. That's okay. So we'll go 5,280 feet in 1 mile. All right, and that's going to give me my answer in what? Well, let's see. Inches cancels with inches, feet with feet, and what do I have left? Well, let's see. I have a mile. I have an hour. Well, that's great. Miles per hour. That's what I want. So, answer will be in miles per hour. Now, all I have to do is type that in my calculator. The whole thing on the top divided by the whole thing on the bottom, and I'm like, I'm done. That's it. All right, so let's see. We got 197 times 13 times 2 pi. Okay, times 60. Enter. Okay, that's the whole top. Divide. Now, parentheses on the bottom, guys. Parentheses on the bottom. So we got 12 times 5280. Close that off. Enter. I got 15.23 miles per hour. So 15.23 miles per hour. So if you put that Corvette in first gear, hold it at 2,000 RPMs, assuming 2 things, which I'll tell you in a sec, you'll get 15 miles per hour. Now, there are 2 things we are neglecting to keep this at a high school level class and not like a college level stuff. And that is air resistance and friction. Those are 2 more complicated equations I don't feel like diving into today. So, assuming you were driving it like maybe in outer space or something like that, where there's no air, I don't know. I don't know how that would work, okay? But let's think about it. Does that make a big difference at 15 miles per hour? Not really. Anybody drive down the freeway, roll down your window, stick your arm out it? And you're like, you're trying to fight it? Yeah, okay. That force is being applied against your car, which will actually throw these numbers a little bit off, okay? So we're neglecting that for the sake of keeping this, high school level, okay? All right, good. Anybody got questions on that? No? Okay. All right, ready? Watch how fast I'm going to catch the answers on this one. Ready? Here we go. Boom. Oh, that was fast. I didn't see anything. You didn't see anything. All right. Now, this is kind of a cool exercise, all right? Because what I did is I found all the gear ratios for the transmission in that Corvette that I want so bad, okay? First through 6th gear and reverse. This is reverse down there. It's negative, right? All right, so what we're going to do is we're going to find the top speed that you're capable of doing in each gear ratio. So we know from previous lessons that if we take an engine past its red line, what can potentially happen? It can blow up, right? You could potentially melt a piston. Pistons are only designed to go to a certain speed, right? We talked about that with piston speed. So if we know the manufacturer's suggested red line maximum RPMs is 6,600 on this Corvette. That's an actual number. It's not supposed to go past that. If I were to put it all the way to the red line, right, 6,600 RPMs, and I were to keep it in first gear, how fast would this bad boy get going? That's a question for you. What do you think? How fast can I go in first gear in a Corvette all the way to the red line?
25.
25 miles per hour? Okay, maybe. I don't know. 40? 40? No way? Corvette? I don't know. All right, so I'm putting the pedal to the floor. I'm keeping it in first gear. How fast is it going to go?
About 30.
30? 40? So we're saying 30, 40. All right, this Corvette, though, right? This thing was racing a jet. 50? Okay, let's find out. There was the hook. Here comes the finish. Okay, first gear. We already know what the combined gear ratio is. It's this times 3.42, right? Which gives us 10.1574. That is the gear ratio we're going to use. Well, now, we're going to do the same problem as the last example, except my RPMs is no longer 2,000. It is now 6,600. Okay, so let's try that example out. Remember, the velocity is equal to the angular, hold on, I'm ahead of myself. Hold on, slow down, Mr. Green. Okay, sorry, my bad. All right, so the angular velocity, we need to talk about that, right? That's going to be what? It's going to be the revolutions per minute, which is 6,600, divided by the gear ratio combined, which is 10.1574. It's going to give us a number. We need that number. I don't remember what it is, but my calculator does. Let's see. 6 what? All right, we're getting two totally different answers there. I'm gonna have to show you. All right, hold on. I'm not saying I don't trust you, but I don't trust you. I'm not saying I don't trust you, but
Just don't trust the brain.
okay. I got 650, right? If you round up, you get 650. So you get 650 RPMs. Okay, so that is the rotational speed at the wheels for a Corvette. Okay. All right, so let's keep it in first gear. All right, so here we go. Keep it in first gear, taking it to the limit. How fast can this thing go? All right, so velocity or angular linear speed is going to be the angular speed, which is 650 revs per 1 minute. Okay, now I got to do some canceling. So now I'm going to multiply that by the radius. The radius is still 13 inches. That didn't change. 13 inches, 1 radian. Okay, now just like your example from the last part, a radian and a rev kind of cancel if you do one of these numbers like this, where you put rads on top, revs on bottom. 1 rev, 2 pi rads. I know that, right? Now I've canceled my rotational force. Now I got to do 2 where I cancel the minutes, hours. So I know if I have 60 minutes, that's 1 hour. Good. Okay. Sorry. Well, yeah, you need that. You just write it to the side. Yeah. All right.
You write it on the table where you put it. So then we're out of room.
That's all right. You can staple too. I don't mind.
Think about it like
Staple.
on paper. And
Yeah.
you write it in a safe space.
I just figured you write small. I don't know. I'm trying to save space in the printer. Okay. Let's go. Last step. Here we go. Inches. Inches go low. 12 inches. 1 foot. 5,280 feet. 1 mile. All right. Let's check units here. Let's check units. Let's see if everything cancels. I think I got it. So minutes. Out. Hours are okay. We like hours. Radians. Revs. Inches. Feet. What do I have left? Miles an hour, right? So I'm down to miles per hour. So we can find out how fast this car can go in first gear all the way to the limit. All right, a little bit of calculations here. Okay, so here we go. We got 650 times 13 times 2 pi times 60. That's it. All right, enter. Divided by parentheses. Make sure you use parentheses. 12 inches times 5280. Close it. Enter. 50.27 miles per hour. Or that car can go, assuming wind resistance and friction are not considered, 50 miles per hour in first gear at the rev line. It's pretty fast. Right? So, if you think about 50, it goes about 50. Yeah. So think about this though, guys. All right, so if it goes about 50 in first gear, in sixth gear, notice the ratio goes from 2.97, almost 3 to 1, down to 1/2 to 1. So wheels are actually spinning faster than the motor, which is kind of cool, right? So how fast do you think this bad boy can go all the way out, no resistance? How fast? Give some numbers. Oh, 100? It's a Corvette, dude. Their speedometers go up to like 200.
20.
Huh? My van goes 100. Come on now.
20.
The minivan goes 100. 200?
Almost.
Corvette, man.
500.
Corvette.
350.
It's the Blue Demon.
500.
It's the Blue Demon.
1,000.
No, not that one. All right. Like maybe 250, 300. All right. I got a problem for you. All right. I got a problem for you. Here, I'll give you a second to copy that down. I got a problem for you. Any of you guys, I'm going to take you back to high school. High school 2000, 2004, 2005. Oh, now you're talking all kinds of crazy stuff. Okay, I'm going to take you back to high school. Movie came out. You guys probably saw it. Let's see. Have you guys ever seen The Fast and the Furious?
Yeah.
All right, there's an epic scene in The Fast and the Furious. Vin Diesel gets in the, what's that guy's name in the movie? Dom. Dom gets in the car. He gets in the gray Challenger. You remember the gray Challenger? He gets in the gray Challenger, or maybe it was a Charger. It was a Charger, wasn't it? Okay, and he's racing the orange car. You remember the orange car? The Supra or whatever it was. Yeah. All right. The Supra's flying down the street, right? And then Dom throws it like backwards, and he's driving backwards just as fast as the guy's going forward. You remember what I'm talking about? Right? He throws it in reverse, he puts it to the floor, and he's driving backwards, staring at the guy in the Supra, right? And the Supra's going forward, they're like zipping down the street. Dom's going backwards, he's zipping down the street. I started thinking, I was like, maybe that's a Hollywood thing. Maybe you can't even really do that. I said, could the Blue Demon do that? Could the Blue Demon go that fast in reverse? Well, this is called the Dom problem. We're going to figure out how fast the Blue Demon can drive in reverse. So, here we go. Ready? Let's find out how fast the Blue Demon can go in reverse. You ready? So, the reverse gear is a negative 3.38 to 1. Negative. So, meaning it's going the wrong direction. Here we go. We're going to figure out how fast it can go in reverse. Okay? So, here we go. What are we going to do? We're going to take the reverse gear and we're going to multiply it by what? What do we multiply it by? Does it have the same differential?
3.42.
Yep. Good. You multiply by the same differential, 3.42. That's going to give us a number, some number, a magical number. Let's find out what it is. Negative 3.8, negative 3.38 times 3.42. I get negative 11.56. Okay, you guys get what I got there? Okay, that's the overall gear ratio. That's as fast as that car can go in reverse. Okay. Now we're gonna take it to the red line. We're gonna put the pedal to the floor. We're gonna go backwards. We're gonna race that Supra right backwards. All right, here we go. Subaru or whatever it is. Okay. All right. So I want to ask you something. So is our RPM limit still the same in reverse? Yeah, it's still the same. We can still go to the floor. So we're going to have 6,600 RPMs divided by that new gear ratio, negative 11.56. Now that negative, not super important here, guys. That's just saying you're going the opposite direction. You can use just regular 11 if you want to. That's fine. All right. So let's work it out. We get 6,600 divided by 11.56. We're going to get 571. 571 RPMs. Okay, now, I know what you're thinking, like, oh, we're going to go through all of that again?
That's crazy.
Yeah.
Man, no. Because in math, what do? We try to make it, we're like lazy as mathematicians. We want to be efficient. We don't have to do all that again. I'm going to show you a little shortcut. What I'm going to say is say, okay, this is the RPM, right? What else is going to stay the same in this original equation? Everything except for what? The first guy. So could we say that this is all going to be the same? Would you guys agree? Everyone's okay with that? That's all the same.
Yeah.
We'll call this the yellow box constant. Okay, the yellow box constant. So, what is yellow box equal to? That's what we need to know. What is yellow box equal to? Because if we know what the yellow box is equal to, we find this number and we multiply by yellow box. That's it. So, what is yellow box equal to? Well, let's go to our calculators. Let's find out. So, calculators, here we go. I'm going to type that in. So, here we go. We got 13 times 2 pi, 2 pi times 60, enter, divided by, parentheses, 12 times 5280. Close it. Enter. I got 0.077, let's be as accurate as we can, 3498. Sure, 3498. That'll work. Okay, there we go. There's our yellow box constant. Our yellow box constant is equal to that. So yellow box is that, and that is yellow box. They're the same. That's what equals means. Okay? So here we go. Let's put it all together now. What we're going to do is we're going to take this angular velocity right here, guys, and we're going to multiply by yellow box. And we're done. That doesn't sound so bad. You like yellow box? Okay. Here we go. So we got 571 times 0.0773498. That's my yellow box. That's going to give me a result in miles per hour because that's what it's set up to do. Miles per hour. So here we go. What do we get? Anybody do it yet? So 571 times 0.0773498. Enter. 44 miles per hour. Okay. So the Fast and the Furious problem has been solved. 44 miles per hour. So when he was racing that guy backwards, he was still inside the speed limit. He was following the rules. He didn't even break the rules. He was still driving in the 45 zone. He was all good. So that's as fast as you can go backwards in this Corvette. It's 44 miles per hour. That's it. Put it in reverse. Put it to the floor. 44. That's as fast as you can go. Okay, yeah, you can finish right. That's it. So there's a good reverse one for you.
I need to call my work.
Call your work. Go in the hallway and call your work. Go get that done. Okay, your goal, guys. Your goal. You got 2 things I want you to do. Well, one, the first thing has 5 parts to it, though. Yeah, so 2 things with 5 parts. All right, so you guys are going to find the fastest speed I can go in 2 through 6. That's not that big of a deal because you know about the yellow box constant, which makes it very easy to do. Okay? Yeah, that's why I didn't give it to you. So you're going to do that. Second goal, you guys are going to get homework tonight. Oh my gosh, homework? What? I didn't get homework all year. You ready? This is what your homework is. What you're going to do is you're going to go home, you're going to Google your car, 2009 Dodge Caravan, so sweet, so sweet. That's okay, you can use mine. And then what you're going to do is you're going to find your gear ratios for your car. I have a 2009 Grand Caravan. It has 4 speeds. It's a 4-speed transmission. I'm going to find the gear ratio for my car. You're going to bring that in the next time, and we're going to find out how fast you can go in each one of your gear ratios for your car specifically. Okay? Oh, 2 things. You need your gear ratio for your transmissions. Okay? You need to find your rear diff ratio, and you need to find the radius of your tires. Just get out there with a ruler. Okay? Oh, I know. So rough. Jeez. Is that all good? You think you can do that?
No.
Yeah. So you're going to find your transmission gear ratios, your rear diff ratio, and the size of your tire, all the way out to the outside tread. And then we're going to figure out how fast you can go in your car. Okay?
I don't even have a car.
All right, hopefully you learned something. As far as the video, we should probably turn that off so it doesn't get too long. All right, so video, we're done. We'll see you later. Everybody else, do some homework. All right.